All right, so we're going to start things off with reviewing some algebra concepts. And the one we're going to start with first is simplifying exponents. And we did this last year. And some of the things that we're going to talk about now are going to take what we did last year and kick it up a notch. But other things are going to be familiar. Just remember one thing is that anytime you have something to the 0 power, so x to the 0 power is 1. A to the 0 power is 1. X plus y, parentheses, to the 0 power is 1. So anything, if we have it raised to the 0 power, is going to be 1. So let's look at these examples down here. So this one, in parentheses, negative 2x to the fourth versus negative 2x to the fourth. So because we have parentheses in this first one, this fourth power actually goes to both things. So this is negative 2 to the fourth times 2 to the fourth, whereas this one is just negative 2x to the fourth power. That fourth power does not go to the negative 2. So then we have negative 2 to the fourth, which is positive 16 x to the fourth. So you see that the parentheses change the problem completely. Right. Now, over here, what I'd like to do first is distribute my exponents. So I have negative 2 to the third. Now, when we have a exponent being distributed to another exponent, we multiply the exponents. So x squared raised to the third power, 2 times 3 is 6. Now we're going to do the same thing with this negative 1. So we're going to have 4 times 4 to the negative 1 power, and then x to the negative third power, because positive 3 times negative 1 is negative 3. So what we need to do first is deal with these x's. We can't deal with those numbers because they're different bases. We have negative 2 to the third power and 4 to the negative 1 power. But when we're multiplying any expressions or variables and the bases are the same, we can add the exponents. So this is going to be negative 2 to the third times 4 to the negative 1 power times x to the positive third power, because 6 plus negative 3 is positive 3. We are not done yet because we need to deal with negative 2 raised to the third power and 4 to the negative first power. When you have a negative exponent, what we need to do is we put that on the other side of a fraction bar. So we always have this invisible fraction bar and over 1. Because this is a negative exponent, only this part is going to go in to the denominator down here. So this is going to end up equaling negative 2 to the third power is negative 8. That 4 now goes to the denominator to the first power, and you don't have to write that in that first power because it's anything to the first power is just itself. But I want to show you that this exponent, once we go across the fraction bar, it changes sign. So I had a negative 1 power, now it's a positive first power. And then we have x to the third. So your final simplified answer is going to be negative 2x to the third, because we can simplify negative 8 divided by 4. So when you're simplifying these expressions, you have to keep going until there's no more you can do. All right, so then this third example, we have this negative third power outside. So we can distribute that to everything. So this becomes x to the positive ninth power, because again, negative 3 times negative 3 is 9. Then y, 4 times negative 3 is negative 12 over 5 to the negative third power. And then 5 times negative 3 is negative 15. So we can move those negative exponents to the other side of the fraction bar, but if you remember, we can simplify that part by subtracting our exponents. Because it's y to the negative 12th over y to the negative 15th, we have y and y. We can take those exponents and subtract them. And then our result will always go into the numerator. So then our answer, our next part is going to be x to the ninth, then y, we have negative 12 minus negative 15. Well, minus negative 15 is going to be plus 15, so y to the third. Then we need to take this, because it has a negative exponent. It doesn't matter that it's a number, that it's 5. It's anytime you have a negative exponent, you bring it to the other side of the fraction bar. Back here, we brought something down to the denominator. Well, here we're going to bring this up to the numerator. It's going to be 5 to the third. Well, we can't leave it as 5 to the third. 5 to the third is 5 times 5 times 5, or 125 times x to the ninth times y to the third, and that would be your final answer. Again, anytime you have something to the 0 power, it's going to be 1. So we have 25 times x to the 0 power. Well, this part right here is 1. So 25 times 1 minus this whole thing in parentheses, 25x is raised to the 0 power. So that's going to be 1. So 25 times 1 is 25 minus 1. That gives us 24. Now this one may look tricky, but it really isn't. We have a plus b in parentheses raised to the fourth power times a plus b raised to the negative fourth power. Well, our base is a plus b. Both of those things are in parentheses. That is our base, so we can add our exponents. So that's going to give us a plus b in parentheses raised to the 0 power, because 4 plus negative 4 is 0. Well, that's just 1. And that makes life a lot easier. Example 6. This is something I know we've talked about before in your previous math classes. Negative 3 squared versus negative 3 squared. If you type this into your calculator, you're going to get correctly negative 9, because order of operations say you're going to deal with that exponent first. So you do 3 squared and get 9 times negative 1, which gives us negative 9. This is negative 3 squared, so negative 3 times negative 3, which is positive 9. So that parenthesis makes the world of difference. Now down here, we're going to distribute this 1/3 power to everything. So 27 to the 1/3 power times x. 6 times 1/3. 6 times 1 is 6, divided by 3 is 2. So this is going to be x squared over 8 to the 1/3 power, y to the third to the 1/3 power. 3 times 1/3 is just 1. Now remember that the third root is the same, 1/3 power is the same as the third root. So this is really the third root of 27 times x squared over the third root of 8 times y to the first power. Well, the third root of 27 is 3, so you have 3x squared over third root of 8 is 2, and then y. We can't simplify 3 over 2, so this is our final answer. All right, next one. We have 6x to the 5th times 3x to the 5th times x to the 0 power. So everything's being multiplied, so we're going to multiply our numbers. 6 times 3 is 18. Now we could simplify this to 1 and then multiply 18 by 1 to get 18. Or we can take all our x's and add the exponents. 5 plus 5 plus 0 is 10. So our answer is 18x to the 10th power. So numerals we are just going to multiply normally. Now, you might say, well, why didn't you do that up here? Why didn't you do negative 2 times 4? Well, because those were in parentheses, and those parentheses were raised to an exponent. And we have to do exponents first before we do multiplication. All right, the last one, see, like in here, we can't do 5 times 3. We have to deal with that fourth power first. So we have 5y to the third times 3 to the fourth times y to the fourth, because this gets distributed, times negative 2 times y squared. Well, 3 to the fourth power is 81. So 5 y to the third times 81, y to the fourth times negative 2 times y squared. Okay. So now we can multiply our numerals. 5 times 81 times negative 2. So 5 times 81 times negative 2. We get negative 810. For multiplying the numbers, and then y, 3 plus 4 plus 2 is going to give us 9. So our final answer is negative 810 y to the 9th. Right, so like I said, this should have been a little bit of a review. Just, as you're doing things, hopefully you're like, oh yeah, I remember this. We talked about this last year. It didn't make a lot of sense last year, but maybe now this cleared those misconceptions up. So thanks for watching. Make sure to like the video and subscribe.